Binomial theorem is a topic that we are going to handle now. It's a subtopic that is, you see, we are going to use to expand brackets. Now, recall from the past course prior, we say that to expand this is how you expand such a bracket. And now, we say that this bracket, this expansion works if n, this n, is a positive number, and that number should be a whole number, or what we call an integer. So it doesn't work for fractions, it doesn't work for negative powers. Now, if you want now to use the one that works for all powers, whether positive, negative, all numbers and fractions, then this is the one we are going to use. How do we derive it? We derive it from this one. What do we say? If our a is 1 and b is x, now this from this is here. Now, where there is a, I'm going to put a 1 as you see. So from here, my a is 1. Then my b is x power 1. My a is there. My a is there. 1 power n minus 2. This is n minus 2. Then my b is x. When you simplify 1 power anything is 1. That's why you see 1 times this, then times x, you get this. Here also 1 power anything goes to 1, and so on. These are the other terms. When you look at the power 1, we have n. Power 2, we have n minus 1 to factorial. So the power goes with the factorial notation down there. And also when this is power 3, the last here is 2. If this is power 2, the last is 1. And if it's power 1, so that there we have n minus n already. So the value for this expression is started by the modulus. You get the modulus of this thing should always be less than 1. Let us see how do we use it. Expand 1 minus up to the term in x cubed. State the variation. Now, these are how we count the term. This is the one term, the second term, the third term, the fourth term. So if they say x cubed, in simple terms, they're asking you to get the first 4 terms. You don't exceed there. Now, this one shows that there are other terms coming. But now the question is just limiting us to the only those up to x power 3. So I always put plus these 3 dots to show that there are other terms which are coming. These are endless series. Whenever we have a fraction, it's an endless series. So now what you do, our formula is this for all terms. Then we start comparing. You compare 1 is 1. This works if this is 1. If it's not 1, then we first make it 1, as you are going to see in that example there. Okay, so now I start this one. I have 1, it's 1, there I am okay to proceed. Now x, in the place of x, we have this. Then in n is this. I'm not saying this is not x is equal to negative. No. X is represented by this in this bracket there. Then others now is just substitutes. So we are substituting in this formula because we have already R1 is 1, then we are free to go. So when I put in this formula, I have 1 plus my n is negative R third, then my x is negative 3x over 1 factorial. 1 factorial. Then plus my n from here is negative R third. Then the n, we subtract a 1. Then we get negative 3, the whole squared, over 2 factorial. Now plus my n, which is negative R third. Then the n minus 1, negative 1 over 3 minus 1. Then the n minus 2 is negative R third minus 2. Then in brackets, I have negative 3x, the whole cubed, plus other terms coming. Okay, so now if I simplify this, my bracket is going to be 1 minus 3x power negative R third equaling 2. Now, you say negative and negative, it's going to give us a cost. So I have 1. This is going to be R third negative has disappeared. 3x. 1 factorial is 1. Then plus. Let us simplify. Now, you always remove this as a fraction. So 2 factorial is 2. So this one is going to be now 1 over 2. This one, 2 factorial, remove it as a half. Then this one will be 1, negative 1 over 3. Then we simplify this, we get negative 4 over 3. Then when you square negative, we get 9. When you square x, we get x squared. So this is already there. Then here, we had 3 factorial. Then plus. 3 factorial is a 6. So remove it as 1 over 6. Then this will be negative a third. This one is negative 4 over 3. And this one, when you simplify, 6 is going to be negative 7 over 3. Then this one, when we cube a negative, okay, I'll make it here. When I cube this negative, I'll get 27, but minus. Anything cubed, it brings its sign, then x cubed plus other terms coming like that. So now, when I simplify this will be now 1 plus x. This x cancels, this upper cancels. So this will be now, this is going to be now minus to get the positive. So that now I'm having this as 4 times 9x squared, the whole over. Now this is going to be 2 times 9, this and this. Then plus 1 over 6 times negative, positive, negative, and this negative, they will disappear. So I mean with 4 times 7 times 27, the whole over. Now I have 3 times 3 times 3. Then my x cubed. Show that other terms coming. So now here you can simplify the whole thing. 3x power negative a third as 1 plus x. You see this 9 disappears by this 1, by this 2. So I have there plus 2x squared. Let us see here what's disappearing. You see this is going to give us 27. So the whole of this is going to be 27. So here by 2, by 2, 3. And think you see 2 times this. So we have plus 2x cubed, the whole over 3, plus other terms coming. And so we have expanded that with is. Now the validity. Now we say the validity is always x modulus of x less than 1. So here it's that our x is this. Our x, we say that always it's x less than 1. So now our x is this. So this is going to be negative 3x less than that. But we say the modulus converts everything to a positive. So this will be now 3x less 1. And from there, this will be negative 1 less 3x less 1. Divide through by a 3 this side. You get now negative 1 over 3 less 3x by 3 less 1 by 3. And this will give me negative 3 less x less 5. And that will be the validity. Or else, we make x, it should be independent of anything except 1. So x, there, make it the subject. I mean, we make it independent of any coefficient other than 1, like that. Okay, so that's how we handle that members. Okay, so when you come now to this, remember here there is a plus, please. But, no, it's not the plus, but I'm just putting that in coefficient. The blackboard wasn't big enough. Anyway, here the idea don't forget is when you cube anything with an odd power, it retains its sign. So be careful. But these 3, 4 negatives, they gave us a positive. Anyway, let us come to this. Now here in my solution, you see that I have a problem. First of all, we know that root 2 plus x is the same as 2 plus x power a half, because that's how we write a root. But now, you see that now my first term is not a 1. This one works if the first term is 1. So all we do, we first make this a 1. What are you going to do? So if I have now my 2 plus x power half, to make it a 1, I factorize out to 2. We factorize out this thing which is known to 1. So if we factorize it out, I have 1 plus x over 2. Instead, what we factorize, we divide it down. So, but the whole of this thing is to power half. Now, this power is to this and to this. So this will be now 2 plus x power half will give me 2 power half, then 1 plus x over 2 power half, using properties of indices. And there is that this will be now root 2 into now 1 plus x over 2 power half. Now it's that this one is a 1. Now if I consider this, then after we multiply what we get with a root 2. Now we say consider now 1 plus x over 2. Always factorize what we factorize out, we divide it out. When we divide here by 2, we get 1. We divide here by 2, we get this. As simple as that, power half. You start now from here. This is our n, and this is our, in the place of x if we compare. Now if I'm to put it there, I'm going to be having now 1 plus my n, which is half. Then plus my x, which is x over 2. Okay. Then plus my n, I'm putting in this formula, my n, which is half. Then a half minus 1 into now x squared, x over 2 the whole squared, then plus a half into a half minus 1, then a half minus 2, and then x over 2 the whole cube, plus other terms coming. And remember, this one is having 1 factorial, this one is having 2 factorial, and this one is having, because of the power 3, is 3 factorial, like that. Then the remaining task is to simplify. Now from here, my 1 plus x over 2 power half, it will be, now you see, okay, let me first write it here so that we fall it down to this step. Here, so I have now 1 plus a half times this, we get x over 4. 1 factorial is 1. Then plus, I have a half into a half minus 1, we get, when I square this, I get x squared. Don't always forget to square also the denominator. When I square this, I get a 4. Then times 2 factorial, we say is a half. 2 factorial is 2, sorry, we remove it as a half. Then plus, here I have a half. This is negative a half. And then this is going to give me negative 3 over 2. When you simplify that, and then when I square this, I get x cubed over 8. When you cube x, you get x cubed, when you cube this, you get that. Then plus other terms coming. Now from there, we can simplify at once. So we have now 1 plus x over 4. Now, you see minus, minus, minus. So positive times a negative, you get a negative, so we have minus x squared over 4 times 4. Because this is 2 times 2 is 4 times 4, we get 16. Then times this half, which is going to give us the 32. So we get this times this 4 times 4, 16 times 2, that's going to give us 32. Then let us see here, minus minus to give us a positive. So we have sorry, I forgot this. This is 1 over 6 to the factorial. So don't forget that for us. Then plus. Negative, negative to give us a positive. So when I have, you look at this, I'm going to have now, you see, by 3 here 1, by 3 here I get 2. So I have now x cubed is surviving over 2 times 2, that is 4 times 2, that is 8. 8 times 8, that is 64. Times 2, that's going to give us 128 plus other terms coming. Now, this is the expansion for this, but remember, the whole of my original expansion, my original bracket was 2 plus x power half, and you said it's going to be root 2 times 1 plus x over 2 power half. So now, here just multiply it with the root 2. So my root 2 into now, the expansion for this was 1 plus x over 4 minus x squared over 32 plus x cubed over 128 plus other terms coming. So now my 2 plus x power half is going to be, this times this, you get root 2, then plus root 2 x over 4, then minus this times this root 2 x squared over 32, then plus root 2 x cubed over 128 plus other terms. So that's how we handle that. Now they must say our validity. So our validity. Now the validity we take for this expression here, the one with 1, it's going to be now our x over 2 less than 1. Since that's already positive, all we do, we expand this as negative 1, x over 2 less 1. So now to remove, we said this should be on the x, we multiply through by 2. So by 2 there, we multiply by 2 disappears, then by 2 there. And that will be our validity. Now, I want you to take note that for this, that we have been having ascending powers of x powers have been increasing. Now you are going to see what happens if they are descending powers. If the question doesn't specify, you treat it as in the form of ascending powers. But in descending powers, the question will specify, and we shall see what happens there. I wish you well.